Okay, so where we're going to be ending our discussion of organic chemicals all surrounds this idea of isomers. And to demonstrate this idea of isomers, I'm going to use this example first. So here's a simple sentence. The fat dog shook himself and then rolled over on the wet rug. So I have certain words that I've used in a certain order. What if I were to take every single word and use it again, but if I alter the order? The dog shook the fat rug, then rolled over and wet on himself. Obviously uses all the same words but have very different meanings. And so is the same with isomers. So isomers are basically the same chemical formula, as in the same number of carbons, hydrogens, etc., but they're in different arrangements. And as a result, you get different unique chemicals, sometimes with varying properties. So the easiest way to do this is just to jump right in. We're going to start with some simple ones with a certain number of carbons, like C5H12. And to make it easy, I'm going to go ahead and tell you the number of possible isomers that you can draw. Now, the key as you're doing this is to be organized and systematic. If you just jump in and start trying to randomly draw stuff, you will inevitably draw things that are the same. They may look different, but they have to have different names in order to be different structures. So if you just kind of jump in and do it off the cuff, you're going to end up wasting a lot of your time. So I'm hopeful that I can show you a way to do this very systematically and do it in a very organized way, exploring all the possibilities, and you'll be able to do it very efficiently. Okay, so let's start with C5H12. What is the most obvious version of 5 carbons and 12 hydrogens? Well, hopefully you're thinking, how about 5 carbons in a row? Looking something like that. Remember, we start counting 1, 2, 3, 4, 5. We know it follows the formula CnH2n plus 2, so we assume the hydrogen's there. That, of course, is called pentane. Okay, so far so good. To do this in a very organized fashion, the next thing we want to try is what if we shorten the longest carbon chain by 1? What if instead of having 5 in a row, we have a 4 carbon long chain, and then we use that extra carbon as a branch? So think about the possibilities there. Maybe it looks something like that. 4 carbons in a row with a carbon coming off the second carbon right here. And of course, 1 carbon right here is a methyl group. So if we go through and name this would end up being 2-methylbutane. You'd have to number from right to left in this case. Okay, so then you want to exhaust all the possibilities. What if you took that carbon and moved it here? Would that give you a unique structure? And I encourage you to try this, but once you do it, I think you're going to find that's also 2-methylbutane. Okay, you've just rotated it, because remember, you have to switch the numbering system. And of course, I can't put the carbon over here, because then that just lengthens the longest carbon chain. So we've exhausted all the possibilities with 4 carbons. What if I did 3 carbons in a row, but now I still need a total of 5, so where could I put other potential carbons? Well, maybe I do 2 methyls. Now, I think you probably realize you can't put those carbons on the outermost ends because that'll lengthen the longest carbon chain. It's got to be on the interior carbon. And so then the only other way to do that is to have 2 methyl groups coming off that middle carbon. So 3 carbon long chain with 2 methyls coming off. The name for that would be 2,2-dimethylpropane. The other thing that I would encourage you to think about is, are there other versions of a 2 carbon branch? Okay, so I'm going to draw this one. What about if we did a 3 carbon long chain, like so? What if I did a 2 carbon branch like this, as in an ethyl? So is that a unique one? Would that be 2-ethyl propane? Seems legitimate, right? Looks different than everything else. But you have to be careful here, because in this drawing, you'd have to change your orientation, and it turns out the longest chain is 1, 2, 3, 4. That's a butane. You've already done that one. That's a butane with a methyl coming off the longest carbon chain. So you have, in fact, already drawn that. So that's why I say I really caution you to do it systematically. Don't just try to randomly jump in and start doing things, because inevitably it's going to end up being a waste of your time. Okay, let me get rid of this here. I really just want an arrow. How do we get an arrow? I I don't want a laser pointer. Aha. Okay. So those are the only 3 that work, believe it or not. Okay, what if we do 6 carbons? So the very first one, 6 carbons in a row. What is that called? Hopefully you came up with hexane. Okay, that's the only way you can draw 6 carbons in a row. So let's do it very systematically. Let's rip off one of the carbons from the end and then try it elsewhere along the chain. Okay, so maybe you move that one branch here and move it here. What's the name of that one? So pause the video if you need to, practice this. We have 6 carbon long chain. You'd have to number it right to left. That is a methyl group. So hopefully you came up with 2-methylpentane. Is that the only methylpentane that you can come up with? Or could you instead move that carbon maybe here? And so then you come up with, and again, pause the video if you need to, that would be 3-methylpentane. What about 4-methylpentane? Let me draw that one. So what if I had 5 carbons in a row, and then what if I had a methyl here? Is that a unique one, 4-methylpentane? Well, you might notice that this one right here looks a lot like this one right there. And if you actually did that one, you would have to renumber it, and this would still be 2-methylpentane. So that is not a unique structure. Okay, so then we go on to potentially a 4-carbon long chain, but we still need 6 carbons. So something we could try is maybe a 2-methyl and a 3-methyl. So we get 2,3-dimethyl, 4-carbon long chain is a butane. So then the question becomes, is there another way? Are there another set of dimethyl butanes that I could do? Well, there's nothing that says you can't put 2 methyls on the same carbon. So here's my 4-carbon long chain, 1, 2, 3, 4 on the second carbon, 2 methyls, that's a 2,2-dimethyl. Could you do a 3,3-dimethyl? Well, hopefully you're saying that no, you can't, because that would actually be the same as a 2,2. Could you do an ethyl butane? Why don't we try that? I'll draw that one out. Sorry, this is the type of lesson that it would be very helpful to just be able to draw this on the board. So could I do an ethyl like that? Ethyl butane, 2-ethyl butane. Well, but if you look though, this now becomes the longest carbon chain, so this is actually a 3-methylpentane. This is the same as this, because though these are all single bonds and so they freely rotate, and that's hard to visualize, but the key is you have to name the structures as you draw them, otherwise you are bound to make repeats. So it turns out those are your 5. Those are the only 5 that you can actually draw. Okay. So let's move on to the next one. We're up to 7 carbons now. Now, if you recall from that first slide, there are 9 possible. I would encourage you at this point to pause the video and give it a try. So you're going to do 7 in a row. Then you're going to try 6 in a row and try to put methyls in different unique spots. Once you've done that, maybe you'll try 5 in a row. And then you have to have either 2 methyls, or maybe you could make an ethyl work. Then maybe you could try 4 carbons in a row, but then you need to have 3 total carbons as branches. So do you see what I mean? If you think about this very systematically and do it in an organized fashion, you can exhaust all the possibilities and find all the ones you need to. So there are 9 of these. Pause the video and give it a try. And again, draw and name as you go. I see students all the time just trying to draw different structures, and it's going to be a waste of your time because you're going to draw something that looks different, but you're going to find that it ends up actually being the same thing. It has the same name, and thus it is not different. Okay, so pause the video and give that a try, and I'll go through the answers here in a second. Okay, so hopefully you had a chance to give this a try. Simplest place to start is 7 in a row. That's your heptane. Okay, that's all you can do with 7 in a row. So what about 6 in a row with a 1-carbon branch? Well, there you go. Try to visualize this. I'm just going to take that carbon and then just rip it off, cut right there, and then I'm just going to move it to all these different spots. So that becomes 2-methylhexane. Could I do other methylhexanes? Could I do a 3-methylhexane? Yes, I can. What about a 4-methyl? What if I move this methyl down here? Well, hopefully you tried that and then notice, wait a minute, that would change the numbering and it would still be 3-methylhexane. Okay, so we've exhausted all the hexanes. Now we need to try pentane, 5 carbons in a row, but we need 2 carbon branches. Now there are several of these, so I'll probably end up going in a different order than you did. Here's the first one I came up with. 5 carbon long chain with 2 methyls. Numbering scheme would be 1, 2, so that is 2,2-dimethyl. Remember, carbon can have up to 4 bonds, right? It can have 8 electrons. So then think about how else could I arrange those 2 methyls? I could do something like this. This would be a 2,3-dimethylpentane. Okay, what about this one? This would be a 2,4-dimethylpentane. I could also do this. This is a 3,3-dimethylpentane. Now you probably have figured out you can't do 4,4 because that would be actually the same as 2,2 if you flipped it around. Okay. So then, have we exhausted all the dimethyls? Now, we haven't been able to do an ethyl yet because the ethyl always lengthened the longest carbon chain until now. You can actually put an ethyl on that middle carbon because no matter which of the longest chains you pick, you get the same name, which is 3-ethylpentane. All right, so I think we've exhausted all the pentanes. Now we're moving on to butanes. So 4 carbon long chains, but we have to have 3 carbons as branches total. And actually the only one that works is this one right here, which is a 2,2,3 trimethylbutane. You can't do a 2,3,3 because the numbering would reverse. You can't do an ethyl here because that would lengthen the longest carbon chain. You can't do a propyl, and so that's it. Those are the 9 that you're able to draw. So I just wanted to show this to you for fun. I remember in college there was a formula that determined this, and I must have made it up because I can't find it now. Here are the number of carbons, 4, 5 on up. Here are the number of isomers that you can have. Now we've already done pentane and hexane and heptane. Octane, there are 18. 9 carbons, you can do 35, 10 carbons, 75, and just look at these numbers. 11, 12, 15 carbons have 4,347 different versions. And I know that seems crazy, but if you really start to think about it, you get a lot of possibilities. So your homework tonight is to actually draw the 18 isomers of octane, C8H18. So again, you would start with 8 carbons in a row, then you'd go to 7 in a row and try to find a room for a methyl. Exhaust all of those possibilities, then go to 6 carbons in a row with maybe 2 methyls, maybe an ethyl. Okay, and go through and do all those, and there are a total of 18. Now, I am going to wait to post the answer key. Well, no, I won't either. I'll post them both, but really do give this a try. This is a good mental exercise. It'll really force you to think. And again, draw it and name it. That's going to help prevent you from making some silly mistakes. But really do give it a legitimate shot, and then check out the answer key. And then we can talk more after that. Okay, I'm going to go ahead and stop there.